Hi everyone, presentation on the topic modeling of 6061 T651 aluminum alloy stress strain diagram by machine learning method is presented to your attention. So improving the reliability of the responsible structural elements and avoiding the industrial accidents is an actual task. Therefore, the prediction of material stress strain diagram is of high importance. So methods of experimental studies are often complicated and expensive. So in particular, with a large amount of experimental data, they need to be generalized, that is, to find the dependence that the most accurately approximates them. So therefore, in this case, it is advisable to use machine learning methods to solve such problems with great accuracy. So the aim of the study is to predict the stress strain diagram of 6061 T651 aluminum alloy at 6 different temperatures: 20, 100, 150, 200, 250, 300 degrees Celsius, using machine learning methods, in particular the methods of K-nearest neighbors and the methods of random forest, and as a result to compare the obtained results. So many scientists apply various methods of machine learning to fracture mechanics, in particular to predict the fatigue regrown rain, determination of stress intensity factor, estimation of stress strain diagrams of aluminum alloy. So the stress strain diagram of this alloy should be predicted by the methods of supervised learning, that is, the K-nearest neighbors and random forest. So here you can see the 3 ways for machine learning. First, the supervised, unsupervised, and mixed. For example, in first case, interpret teacher participation as a knowledge presented in the form of input-output couples. The network parameters are corrected the difference between the desirable and output signals of this network. In second case, for unsupervised learning, a network with this class cannot know the correct answer for to each samples of training samples. Yes, in the mixed case, the part of the weights is determined by supervised learning, while the other is obtaining when the network is self-learning. So let's move to the first algorithm of K-nearest network. So this method, for example, in particular, it's a basic idea in the new object to predict belongs to the class that is most common among K-nearest neighbors. Yes, so the distance between K-nearest neighbors is usually Euclidean. The methods of machine learning is the algorithm for supervised learning. So, for example, it requires a market data set. So to show, for example, analysis, let's consider that the task of new object, you can see here the query point among the number of known example. So in other words, we want to know whether the query point can be classified as plus, yes, or as minus. To continue, let's consider the results of K-nearest neighbors based on one nearest neighbors. It is clear, so in this case, the method of K-nearest neighbor will predict the results of the query point with the minus. It is because, for example, these elements, yes, you see is near the other query points. So when we have regression problems, the results of the query point are supposed to be the average of the results of its k-nearest neighbor. So another method of machine learning is random forest. In particular, the algorithm constructs a set of decision tree and the results of their prediction. An important element is, for example, randomness in the creating of each tree. If you, for example, create many, for example, many identical trees, yes, the results will be the accuracy of one tree. So, for example, the development of a certain model of machine learning excludes, for example, of following stage. First stage will be the preparation of data, the next construction, the algorithm, its training or learning data, and verification by using the test data. For example, in order to modeling the diagram of stress-strain, the stress-strain diagram, yes, we use some experimental data in this paper. So here you can see that the stress and the temperature are selected as the input parameter, while the strain as output parameters. In general, during learning, the data set is divided into two unequal parts, learning and test sample. For example, to the learning test, we use 80% of our set were randomly selected for the training sample from all experimental data and at different temperatures. And 20% were left to assess the quality of prediction. Here you can see the prediction and experimental data of linear region of the strain of different temperatures obtained by methods of k-nearest neighbors and random forest. I'm sorry, I want to talk you that in general, the stress-strain diagram was divided into two regions, that is a linear and non-linear, to improve the quality of prediction. So as a result, we built the two networks. So here you can see the predicted and experimental data for a linear region. Of the strain for different temperatures obtained the first method of k-nearest neighbors and the random forest. So in this case, it was nothing noting, yes, that the points are quite close to the bisectors of the first coordinate angle, which, for example, reveals good agreement with experimental and predicted results. Here you can see the predicted and experimental dependence of linear region of the strain for different temperatures obtained by methods of k-nearest neighbors and a random forest. So this is a prediction of experimental data of non-linear region, the first method of k-nearest neighbors and the other random forest. So here you can see the prediction and experimental dependence for non-linear region of the strain for different temperatures obtained by first method k-nearest neighbors and random forest. So here the dependence of the root mean square error on the number of trees for linear and non-linear region obtained by two methods of machine learning. So this is the importance of input parameters, that is stress and temperatures. You see that the stress is very important parameters in our investigation. So this is the parameters that we use in order to build our networks. For the first method of machine learning, we use the k-nearest neighbors will 10. Yes, it means that we have 10 nearest neighbors for linear region, and for non-linear, we have only one nearest neighbors. In order to talk about random forest, you see that we use 100 trees in order to build the network. So in this study, the loss function was mean absolute percent error, and the error of 9.6% and 5.9% respectively were obtained by the methods of k-nearest neighbors in the test sample. The errors of the random forest method were 15% and 13.7%. So it was found that the prediction results are in good agreement with the experimental one. So thank you very much for the attention.